my dear students. Let's start the session.
Case number 10. Right up. Here. Now the rod is pivoted. Rod is pivoted at this point. This is the rod. Rod of mass m. Circular rod of mass m. Length L. Length L. So here, stiffness of the spring. K is the stiffness of the spring. Mass of the rod. Length of the rod. It is pivoted at this point. Clear? So in this case, mass of the rod should be considered. Weight of the rod should be considered. Weight acting downward. Okay, na? Deformation is horizontal. This is vertical lever problems. Vertical lever. In this case, weight of the rod must be considered. Clear? So here, what we need to do? We need to disturb the system. We need to disturb the system. Here to here. Disturb the system. Theta. This is the disturbance. Now draw free body diagram. Now draw free body diagram. Here to here. This is the rod. Rod. Here to here. So now tell me, weight of the rod. This is G. Weight of the rod always have vertically downward direction. Weight of the rod always have vertically downward direction. Angular disturbance. Angular disturbance. This is theta. If it is theta, it would be theta. Mg cos theta along this direction. Here, mg cos theta along this direction. Mg sin theta would be acting along this direction. Mg sin theta. This is L by 2. L by 2. Moment of weight. Okay, na? So, here inertia torque will be acting opposite to the direction. Inertia torque equal to how much? I over theta double dot. Element mass chapter was over. Weight is represented. Inertia torque is represented. That means the element mass chapter was over. Now coming to the spring. How many elements present in the system? Spring mass. Spring mass. For mass, weight and inertia torque. Clear? If I give this kind of disturbance, what is the deformation in the spring? Deformation in the spring. Towards right. Spring force will be acting opposite to the direction. Clear? What is the direction of spring force? This is the spring force. Spring force always act opposite to the direction. K into L theta. K into L theta. This should be L. K into L theta. Are you following? Understood or not? K into L theta. Now apply moment about point 2. Inertia torque represented in the free body diagram means dynamic problem converted into static problem. Apply static equilibrium equations. Sigma mz equal to 0. Inertia torque plus inertia torque. Inertia torque plus. This is how much? Fs into L plus how much? Mg sin theta. Mg sin theta into L by 2. Mg sin theta into L by 2. That equal to 0. Then what if people are getting? I over theta double dot plus k times of L square theta. Sin theta replaced with theta. Mg into L by 2 plus. That is mg into L by 2 theta. Clear? So now tell me, what is obtained here? I over theta double dot plus k times of L square plus mg into L by 2. The moment of weight will be added in the denominator. If weight is considered, that will come in the denominator. Moment of weight will come in the denominator. Theta double dot plus omega n square theta equal to 0. What is the short trick here? What is the short trick here? Time period of oscillation equal to 2 pi square root of I/O by k times of how much? K times of how much? K times of L square plus moment of weight. Moment of weight is how much? Moment of weight we need to add in the denominator. That is how much? mg into weight is acting at L by 2. mg into L by 2. What is I/O? Tell me. Plus IgG plus m into distance between square. Clear up. What is the distance between square? This is G. This is O. Here O. IgG equal to ml square by 12. Are you following? ml square by 12 plus what is the distance between two parallel axes? L by 2 whole square. ml square by 3 will come. I/O how much is obtained? ml square by 3 will come. Understood? ml square by 3 will come. Now substitute here. Square root of 2 pi square root of I/O is nothing but ml square by 3. K times of L square plus mg into L by 2. That equals to L gets cancelled out. Finally, how much is obtained? Chapandi, how much is coming? Tell me. 3 will come in the denominator. 2 times of ml by 2 times of kl plus mg into 3 will come. 2 times of ml by L gets cancelled out. This square will go. 2 times of kl plus mg. 2 will go to the numerator. 2 ml by 3 times of it. That is the final answer to this question. Time period of oscillation, how much is obtained? 2 pi square root of 2 ml by 3 times of 2 kl plus mg. Understood or not? Here, this is the problem based on vertical level. Completed. Next. Only rod D is mentioned. Are you able to answer? Only rod D is mentioned. In that case, what is the answer? Tell me. No spring. Only rod also one of the previous year question. Only rod is given. What is the time period of oscillation? Tell me. Question number 11. Only rod is mentioned. Here it is pivoted at this point. Clear up. So here what is obtained here? We need to view the disturbance. Mass M. Length L. So we need to disturb this question. The question. Weight always act vertically downward direction. So we gave angular disturbance theta. So then mg cos theta. This is L by 2. mg sin theta. Clear up. So inertia torque will be acting. along this direction. This is the disturbing point. I O theta double dot. Now KL square won't come. KL square won't come. KL square. KL won't come. Are you clear? KL square. Same answer will come. 2 pi square root of. Time period equal to 2 pi square root of ml square by 3. 2 pi square root of I O by. So what is the moment of weight? mg into L by 2. This is your previous year question. 2 pi. This is finally what is obtained. What is the answer to this question? 2 ml. 2 times of ml by gets cancelled out. 2 times of L by 3g. 2 times of L by 3g. 2 times of L by 3g. Clear? Understood? Next. Case number 12. Completed. Next slide up. Double pendulum. Double pendulum. Compound pendulum. This is the question from compound pendulum. How many pendulums in the syllabus? Simple pendulum, compound pendulum and conical pendulum. Total 3 pendulums. Circular motion in conical pendulum. Completed. Next. Now double pendulum problem. Double pendulum problem. Here to here. This is the length L. Length L. Mass of the bob here. This is the mass of the bob. Mass of the bob. Here one spring. Here one spring is connected. K. Here another spring is connected. Here another spring is connected. Another spring is connected. This is also K. This is also K. Here in this case, effect of weight need to be considered or neglected. Effect of weight should be considered because weight acting downward deformation is right side. Vertical lever problem. We need to consider. We need to consider if I give this kind of disturbance. If I give this kind of disturbance. This kind of disturbance. Clear? See this. If I give this kind of disturbance, focus here. I am disturbing the question, disturbing the system. Focus here. This is the mass M. First focus on the element mass. Disturbance. This is the angular disturbance. Focus on the element mass. First focus on the element mass. Weight of the element mass always have vertically downward direction. Weight of the element mass always have vertically downward direction. This length L. Weight of the element mass always have vertically downward direction. Okay, focus. Along this direction how much? This is theta. mg cos theta. mg cos theta and mg sin theta. mg cos theta and mg sin theta. If it is theta, it would be theta. Along this direction, mg cos theta. Along this direction, mg sin theta. mg sin theta. Are you following? Moment of this force above the pivot or disturbing point. Clear? Moment of this force above this point is what? MGL sin theta, clockwise or anti-clockwise. Moment of this force above this point, clockwise or anti-clockwise? Anti-clockwise. Moment of this force above this point, clockwise or anti-clockwise? Clockwise. Okay, now this anti-clockwise moment cancelled with clockwise moments. These two moments will be cancelled. Mg cos theta, moment of this force above this point, how much? 0. Because the line of action of mg cos theta passing through the point O. Clear? So now coming to the inertia. Now coming to the inertia. This is mass 1. If you take mass 1 and mass 2, then what you will get, tell me? Inertia torque always act opposite to the direction of fan off cheyandi. Inertia torque always act opposite to the direction of angular motion. What is the direction of angular motion? Anti-clockwise. What is the inertia torque? Clockwise. Inertia torque I01 theta double dot. Clear? What is the moment? What is the angular motion of this mass? Clockwise or anti-clockwise? Anti-clockwise. What is the inertia torque? This is the inertia torque. This is I02 theta double dot. Element mass chapter was over. Weight and inertia torque will come for the element mass. Now coming to the spring. If I give this kind of disturbance, what is the direction of deformation of this particular spring? Towards left. What is the direction of spring force? Towards right. Clear? So what is the direction of spring force? This is the spring force 1. How much is this? K times, what is the arc length? L theta. So if I give disturbance, it will be elongated like this. What is the direction of spring force? Opposite to this. Are you clear? Understood this? This is the direction of spring force. Fs2, KL theta. KL theta. Now apply moment about point O. Apply moment about point O. Then what is obtained here? Apply moment about point O. Algebraic sum of the all moments about z-axis equal to 0. That is static equilibrium equation. Now, so what is this? Inertia torque, these two are clockwise and anti-clockwise. Clockwise or anti-clockwise? Clockwise. Your disturbance is anti-clockwise. Your disturbance is anti-clockwise. All inertia torque, all moments must be clockwise. Inertia torque. This is 2. Clear up. Plus how much? What about spring force? Fs1 into L plus Fs2 into L. That equal to how much? 0. Here moment of these two must be cancelled. Here mg sin theta. Here mg sin theta into L minus mg sin theta into L. That equal to how much? 0. These two moments gets cancelled. Moment of weight. Okay, see here. What is this? Tell me. I01 plus I02 theta double dot plus K times of L square plus K times of L square theta equal to 0. Then theta double dot plus 2K L square by IOO system about point O, theta equal to 0. So what is the short trick? Here also you will get the same. What is the short trick here? What is the time period? Straight away tell me. 2 pi square root of. Numerator is what? First check. What is the moment of weight is coming or not? We observed that moment of weight of the two bars gets cancelled. In the denominator, no need to write moment of weight. Numerator, what numerator will come? IOO of the entire system. Entire system by how much? K times of L square plus K times of L square. 2 pi square root of. What is IOO system? Tell me. Two masses only na. ML square, ML square. M times of L square plus ML square. ML square, 2KL square. So finally, what is the time period of oscillation for given double pendulum problem? 2 pi square root of M by K will come. M by K will come. This is the problem based on double pendulum. Two pendulums, double pendulum. T equal to how much? Final answer 2 pi square root of M by K. 2 pi square root of M by K. Are observing? When we need to consider the mass, weight, when we need to consider the weight, when we need to neglect it, that part you should be very clear. Clear. Here we considered what moments are balanced. Understood? Next slide up. Completed. Next coming to one of the previous year question. Question number 13. Annular disc or halo disc. Annular disc or halo disc. What is the mass moment of inertia of the halo disc or so called annular disc? Okay, what is the question? 12 or 13?
30.
Question number 13. Okay, so now I am focusing on annular disc. Focus here. This is the annular disc. Inner radius is, this is pivoted at this point. Pivoted at this point. Hinge joint, hinge. Pivoted or hinge. Annular disc. Inner radius is R. Outer radius is 2R. Outer radius is 2R. Entire part is the mass. This is the mass. Okay, this is the mass. Understood or not? Inner radius and outer radius. Okay, inner radius and outer radius. Are you following? Pivoted at point O. Pivoted at point O. This is the center G. Center G. So here, halo disc of mass M. Radius, inner radius and outer radius. This is halo disc or annular disc. Annular disc. Halo disc or annular disc. We need to discuss what is the mass moment of inertia of halo disc. Tell me. IgG equal to how much? Outside. About z-axis. About z-axis, tell me. Mass moment of inertia of the annular disc about z-axis. Z-axis. M into outer radius square. Here, how many of you feeling? M outer radius square, inner radius square, by how much is obtained? 2 will come. Here plus or minus. How many of you feeling minus? How many of you feeling minus? I am asking mass moment of inertia. Minus. Pakka minus. Granted. Plus will come. Okay na? Here it is not minus. Plus will come. We can derive it. I will derive it. Clear? So it is, if you want I can derive now itself. Density is constant. Density is constant. Density is constant. Mass by unit volume. Mass by unit volume is constant. Mass by unit volume is constant. Now tell me, mass of the, here we need to talk about hollow disk. How to get hollow disk, tell me. This is inner. This would be outer. How to get hollow disk? We need to remove some mass from the solid disk. This is the mass of the solid with radius how much? R0. This is mass of the solid disk minus. Here you can take a hole. This is how much? Hole. What is the hole? M hole. Mass of the hole. What is the radius of the hole? Inner radius. This is negative mass. Mass of the hole is what? Negative mass. If you remove this much amount of disk from the solid disk, if you remove this much from the solid disk, you will get a hollow disk. What is the mass moment of inertia? So in this case, how to write? Mass of the solid, mass of the hole. Given mass is how much? M. Given mass is how much? M. Mass by, if you write that constant base, what is the mass by? Mass by, what is the volume of the hollow disk? Pi. R0 square minus R inner square into thickness T, pi R square T. Next, mass of the solid by how much? Mass of the solid by how much? Pi R0 square into T. This is how much? That equal to mass of the whole. Mass of the whole. This is the solid portion. This is whole portion. Inner square into T. From here, what is the mass of the solid portion? What is the mass of the solid portion? If it goes to the left hand side, M into R0 square by M into R0 square by R0 square minus R inner square. R inner square. What is the mass of the whole? What is the mass of the whole? Confidently tell me. M into R inner square by R0 square minus R inner square. Clear? Mass of the solid and mass of the whole in terms of mass of the annular disk. In terms of mass of the annular disk, I am interested in IgG of the hollow disk. This is inner and outer. That equal to how much? That how to get it? IgG of solid one. This is the solid one. Are you following? Solid one. Solid. Entire part is solid. We need to remove it. Minus. Here we need to remove the whole. I am taking M whole is negative. So we can write like this. IgG of this whole. This is the whole. R inner. This is how much? R outer. Mass of the solid and mass of the whole. This is mass of the thing. Clear? Understood or not? Now tell me how much is obtained. This is how much is obtained. Mass of the solid into outer square by 2. By 2. Minus how much? Minus how much? Mass of the whole into R inner square by 2. Inner square by 2. Clear? What is the mass of the solid? Finally, this equal to how much? Mass of the solid equal to M into R0 square means what? r naught power 4 by 2 times of r naught square minus ri square minus m times ri power 4 by 2 into r naught square minus ri square. Clear? So numerator lo em rayachu cheppu, m into r naught square plus ri square by 2 will be obtained. This you can write a square minus b square into a square plus b square. A square minus b square cancelled out. R naught square minus r inner square gets cancelled out. Finally, what is the expression for IgG? What is the expression for IgG in this case? Tell me. Annular disk. IgG. IgG of this annular disk. Annular disk m into r naught square plus r inner square by 2 plus or minus plus will come. Now coming to m into what is r naught square? 2r square plus r square by 2. This is how much? 5 times of mr square by 2. 5 times of mr square by 2. Now, completed. Five times of mr square by 2. What is IOO? Mass moment of inertia. This is IgG. This is IOO. IgG. IOO and IgG. What is IOO? What is IOO? IgG plus mass into distance between square. Clear? So this is how much is obtained. 5 times mr square by 2 plus mr square. What is the rate distance between G and I? G and O. R na. So then what you will get? 7 mr square by 2. 7 mr square by 2. That is IOO. 7 mr square by 2. Now tell me. Now we need to disturb the system. Now we need to disturb the system. Now we need to disturb the system. It will go to G. Then what will get? Tell me. Here to here. This is the pivot. Here pivot. Entire part. Here it is G. Before G, it will go here. This will be G. Weight always at vertically downward direction. Weight always at angular disturbance. Angular disturbance. Weight always at vertically downward direction. Clear? So along this direction, mg cos theta. Along this direction, mg sin theta. Inertia torque will be acting along this direction. I naught theta double dot. Are you following? Understood or not? అర్థమవుతుందా? అర్థం కావట్లే? ఓకేనా? So here it is theta. This would be theta. This would be theta. Then what you will get? Tell me. Along this direction. Along this direction. mg cos theta. Along this direction. mg sin theta. Inertia torque will be along this direction. Inertia torque I naught theta double dot. Now apply moment about point O. Apply moment about point O equal to 0. Apply moment about point O equal to 0. That is inertia torque plus mg sin theta into this is how much? R. R na. So mg sin theta into R. mg sin theta into r equal to 0. What is the inertia torque here? IO theta double dot plus mg r theta equal to 0. Theta double dot plus mg r by IO theta equal to 0. Now, what is the short trick? What is the short trick here? T equal to how much? 2 pi square root of IOO of the system. IOO of the system by how much? Moment of weight about the pivot point. Weight acting downward. Mg sin theta. What is the moment of weight? Mg into R only na. Mg into R. What is IOO obtained? IOO ఎంత వచ్చింది? IOO ఎంత వచ్చింది? 7mr square by 2. 7mr square by 2. Denominator mgr. That equal to mm gets cancelled out. RR gets cancelled out. 7m by 7r by 2g. Are you getting the same? 7 times of r by 2g. 7 times of r by 2g. Are you getting the same? T equal to how much? T equal to how much? 2 pi square root of 7r by 2g. 7r by 2g. Tell me. mg here denominator. That theta will go here now. This sin theta turn to be theta only, right? Clear? In the shortcut, straight away mg into r will come. Moment of weight only. mg into r. Straight away this mg into r. Clear? అందుకే నేను 2 మెథడ్స్ చెప్తున్నాను. ఇలా ఫ్రీ బాడీ డయాగ్రామ్ ఇస్తే ఈక్వేషన్ వస్తుంది. ఈక్వేషన్ నుంచి డైరెక్ట్గా వచ్చేస్తుంది. అలా కాకుండా ఎగ్జామ్ హాల్లో నువ్వు డైరెక్ట్గా రాసేయచ్చు దీన్ని. ఆ సైన్ థీటా తీసుకోను. అందుకే కదా సైన్ థీటా బికమ్స్ థీటా కదా. మనకి ఏం లేదు, షార్ట్ కట్ అంటే అది మనమే రాసుకునింది. ఈ ఎంజీఆర్ ఇక్కడ రాయాలంతే. అర్థమైందా? షార్ట్ కట్ అంటే మనము షార్ట్ ట్రిక్ అంటే ఫాస్ట్గా చేయడం అంతే. అవి మన కన్వీనియన్స్ కోసం మనం రాసుకునేవి, అంతేగాని దాంట్లో లాస్ ఏమి ఉండవు. ఇక లాజిక్ ఏంటంటే అన్నిటికీ వర్కౌట్ అవుతుందా లేదా చెక్ చేసుకోవాలి అంతే. ఇక్కడ ఐఓఓ న్యూమరేటర్లో వస్తుంది, నువ్వు ఎటు చేసినా అదే వస్తుంది అంటున్నావు. ఇక్కడ డైరెక్ట్గా రాసేయచ్చు కదా అనేసి అట్లా. అంటే మొమెంట్ ఆఫ్ వెయిట్ వస్తుందా రాదో చూసుకోవాలి. రాకపోతే ఫరక్లే, అసలు ఫ్రీ బాడీ డయాగ్రామ్ అవసరం లే, డైరెక్టే రాసేయచ్చు. ఒకవేళ మొమెంట్ ఆఫ్ వెయిట్ ఉన్నప్పుడు ఎట్లా వస్తుందనే ఐడియా కోసం ఫ్రీ బాడీ డయాగ్రామ్ తీసుకొని ఆ మొమెంట్ ఆఫ్ వెయిట్ ఎంతో డినామినేటర్లో రాస్తే అయిపోతుంది. మొత్తం క్యాలిక్యులేట్ చేయబడలే. క్లియరా? అయిపోయిందా ఇది? నెక్స్ట్ రైట్ ఆఫ్ 40. నెక్స్ట్ రైట్ ఆఫ్ క్వశ్చన్ నెంబర్ ఎంత? 13 or 14? 14. See this, you need to answer this question. It's a rod. It's a rod. Here it is pivoted. Pivoted middle, yellow. This is LL. Here the point mass is placed here. M equal to capital M by 5. This is mass M. mass M. Now one spring is connected at the bottom. This is K. Another spring is connected. Another spring is connected here. Another spring is connected here. Okay. So one more spring is connected here. At L by 2. Total length L. At L by 2. One more spring is connected here. This is K. One more spring is connected here. This is K. L by 2. Total length, this is also L by 2. This would be L by 2. Total L by 2, L by 2, L by 2. Pivot point. What is the answer to this question? This is also K. ఇలా ఇచ్చాడు అనుకో ఎలా ఆన్సర్ చేయాలి ఫస్ట్ క్యాలిక్యులేట్ IOO సిస్టమ్ వాట్ ఈస్ IOO సిస్టమ్ that equal to how much IOO of the rod IOO of this particular rod plus how much IO of the point mass rod కి సపరేట్ గా అలా కనుక్కోవాలి క్లియరా సో వాట్ ఈస్ అర్థమవుతుందా సిస్టమ్ కు కనుక్కోవడం వచ్చా మీకు మాస్ మొమెంట్ ఆఫ్ ఇనర్షియా ఆఫ్ ద ఎంటైర్ సిస్టమ్ అబౌట్ ఎన్ యాక్సిస్ ఓవో తెలుసా తెలీదా తెలీదా మొత్తం ఎంటైర్ సిస్టమ్ అంటే సిస్టమ్ లో ఎన్ని ఉన్నాయి రాడ్ ఒకటి ఉంది పాయింట్ మాస్ ఒకటి ఉంది ఓకేనా సో అప్పుడు నీకు IOO ఆఫ్ ద సిస్టమ్ అంటే ఎలా కనుక్కుంటావు IO of the system అంటే ఎలా అనుకుంటావు సో దిస్ IOO and G both are coincide clear distance between square how much 0 ml square by 12 plus how much distance between square how much 0 clear next what is the mass of the point mass కి mass moment of inertia అంటే చెప్తారు mass into square of the distance ఓకేనా ఇది పాయింట్ మాస్ అయితే డైరెక్ట్ వేసేయడమే mass into square of the distance mass into square of the distance mass into square of the distance ఇక్కడ మాస్ మొమెంట్ ఆఫ్ ఇనర్షియా ఎంత చెప్పండి సిస్టమ్ కనుక్కొని చెప్పండి in terms of capital M చెప్పండి how much is uptime in terms of capital M చెప్పండి 17 okay here what you have written here చెప్పండి that is discrete m into 2l whole square by 12 understood mass moment of inertia of the rod about center of gravity what is the length of the rod here 2l is the length of the rod okay na here G and O both coincide that is why mass into distance between square how much this part 0 mass into distance between square 0 IgG is this next coming to point mass m into L square m into distance between square here how much is obtained 4 ml square by 12 plus m by 5l square this is how much ml square by 3 plus ml square by 5 8 ml square by 50 that is IOO system entire system that equal to 8 ml square by 15. ml square by 15. Understood? Now straight away tell me what is the time period of oscillation? Straight away tell me what is the time period of oscillation? Numerator what we will get? IOO system. Numerator IOO for entire system. Denominator what we will get? K into L square plus K into L by 2 whole square plus K into L by 2 whole square plus K times of L square. That's it. Okay, what is the time period of oscillation? T equal to 2 pi square root of I system. IOO system is how much? This is 8 ml square by 15. 8 ml square by 15 by denominator 2 times of 4, 5, 10. 10 kl square by 4. 10 kl square by 4. Are you getting the same? Kl square by 4. 2 times of 4, 5, 10. Denominator 4. 5 kl square by 2. 5 kl square by 2 in the sense. 5 kl square by 2 in the sense 16 ml square. This is 25 into 3 K. 25 into 3. Understood? 4 by 5 will come out on KL square. LL gets cancelled out. So 4 and 5 will come out. 8 pi by 5. Square root of m by k. Here, understood or not? Here 2, 16, 5, 5 3s are 25 into 3. Here. So m by 3k will come. So you are in position to calculate. You are in position to calculate mass moment of inertia. Mass moment of inertia. Clear or not? This is all about some funda related to free undamped oscillations. Thank you. We can meet in the class. 3 minutes ఉంది. ఇంకో ప్రాబ్లం చెప్పండి చెప్తాము. ఇంకో ప్రాబ్లం చెప్పండి చెప్తాము. నాకే ఉంది ఇంకో క్వశ్చన్ అయినా వస్తుంది నాకు. ఇప్పుడు ఎన్ని అయినాయి? 14 అయినాయి. అమ్మా ఇంకా చాలా ఉంది కేసెస్ నీకు మొత్తం రావాలి కదా. సింపుల్ పెండలం ఎత్తుకుంటే 15 కేసులు వస్తాయి. ఇంకా అసలు మన సింపుల్ పెండలంలోకి రాలా. సింపుల్ పెండలం సపరేట్ డిస్కషన్ అది. దాన్ని తీసుకొని పోయి వాటర్లో పెడతాము, ఎలక్ట్రిక్ ఫీల్డ్లో పెడతాము, మొత్తం అది బాగుంటుంది డిస్కషన్. రేపు స్టార్టింగ్ అదే వస్తుంది. దాని తర్వాత పుల్లీస్ వస్తాయి, అది బాగుంటుంది. ఇంకా ఇక్కడే నేను లాస్ ఆఫ్ మోషన్ కూడా చెప్పుకుందామని.